Hello, everyone. I'd like to welcome you to the Technical Assistance for Brownfields Program EPA Region 1 webinar on lead exposure health data. My name is Sarah Wakai. I'm an assistant professor here at University of Connecticut Health Center in the Center for Population Health. I'd like to acknowledge the TAB program leadership, Dr. Randy Mendez and Dr. Marissa Crisocho. The learning objectives for this webinar are review sources of environmental lead exposure, examine health effects commonly associated with lead exposure, explore data sources that monitor lead exposure health risks. Lead is the most common brownfield contaminant. It is a metal that has been used by humans for millennia. It has been a key ingredient in many industrial products, including paint, gasoline, and pesticides. Hazardous levels of lead may still be found in facilities that once used or manufactured lead-based products, such as abandoned foundries, ammunition factories, and farms. Lead contamination from products and byproducts containing lead can also end up in former landfill waste and wastewater treatment plants. The most common sources of lead exposure in the United States are lead-based paint chips and dust, gasoline exhaust, lead-contaminated soil, primarily from lead-based paint, dust, and historic leaded gasoline exhaust, and lead in water from lead pipes and plumbing fixtures. Other sources of exposure include some toys and jewelry, food and candy imported from other countries, traditional home remedies, some cosmetics, and dishes decorated with lead-based paint. Some jobs and hobbies that involve working with lead-based products, such as creating stained glass or spending time at fire ranges, may result in a family member inadvertently bringing lead into the home. While most commercial and industrial uses of lead have been phased out, there are still some products used or made in the United States that contain lead, and it is still used in products made in other countries. A recent example of food-related childhood lead exposure came to light through routine blood lead testing in North Carolina. The investigation expanded nationwide and identified approximately 500 cases potentially linked to cinnamon and apple cinnamon puree pouches. If you would like more information about sources of lead contamination, they are described in detail in the web links below. Lead, like many contaminants, can be introduced into the bloodstream through three exposure pathways: inhalation, ingestion, and dermal exposure. The primary pathways for lead exposure are inhalation and ingestion. Lead can be inhaled or ingested from lead-based paint chips and dust, soil contaminated from lead-based paint flakes, or living in an area with a history of exposure to leaded gasoline car exhaust and manufacturing fumes. Children who live near airports might still be exposed to lead in the air and soil from aviation gas. Exposure from drinking water usually comes from distribution or plumbing lines that lead to lead rather than lakes, rivers, or wells. Entire communities can be exposed to lead through corroded water pipes, as was the case in Flint, Michigan, a decade ago. When reviewing health data related to lead exposure, you may see lead represented as its periodic table symbol, BP. You may also see the abbreviation BLL, which stands for blood lead level. BLVR refers to blood lead reference value. In 2021, CDC updated the blood lead reference value from 5.0 to 3.5 micrograms of lead per deciliter of blood to identify children with blood lead levels that are higher than most children's levels. The BLRV is a population-based measurement. It is not a health-based standard or a toxicity threshold. The value is based on the 97.5th percentile of blood lead distribution in U.S. children ages 1 to 5 years old. It indicates that 2.5% of U.S. children aged 1 to 5 years old have BLLs at or above 3.5 micrograms of lead per deciliter of blood. When you're looking at current health data related to lead, especially in children, you will see this number. There is no known safe BLL because even a small amount can be harmful. Lead is toxic to everyone, but unborn babies and children under 3 years old are especially susceptible because they absorb lead faster and react more strongly to its harmful effects. Pregnant people and individuals who work in certain industries or have certain hobbies may also have higher rates of exposure. Very high lead exposure can be deadly. Moderate to high levels may cause anemia, nausea, headaches, loss of appetite, muscle and joint weakness, and kidney and brain damage. Even low levels of lead can impact the developing child's nervous system, resulting in neurological and behavioral problems such as low IQ and hyperactivity. Since 1971, the United States has seen a dramatic and sustained decline in lead exposure due in part to control of lead sources, emission reductions, federal regulations, and applied public health efforts. The U.S. banned the manufacturing of lead-based paint in 1978, and leaded gas was entirely prohibited in 1996. These and other regulations limited the number of products with lead as an ingredient or products that were exposed to lead through a manufacturing process, making it to the marketplace. However, some of these products may still be in people's homes today. As you can see from this graph, the blue line represents the 95th percentile of blood lead concentration in children ages 1 to 5 years old. In 1976 to 1980, children at the 95th percentile had a blood lead level of 29. By 2020, that number decreased to 2.1. The orange line represents the median concentration of lead in young children, which was 15 in 1976 to 1980 and decreased to 0.6 in 2017 to 2020. The largest declines in blood lead levels occurred from the 1970s to the 1990s, following the elimination of lead in gasoline. Lead exposure is not equally distributed and is an additional burden to communities already at risk for other environmental exposures. Those at greatest risk are young children, those living in housing built before 1978, non-Hispanic, Black, or African American children, children eligible for Medicaid, and children living in areas with higher poverty rates. This graph uses NHANES data from 2015 to 2020. As you can see, the 95th percentile blood lead level in Black non-Hispanic children ages 1 to 5 years is greater than for children who are white, non-Hispanic, Mexican American, or all other races, ethnicities. Among children in families below the poverty level, the 95th percentile BLL was higher than the BLL of children in families who were at or above the poverty level. The majority of the lead exposure health data focuses on childhood lead screening, child blood lead screening, and results. All of the states in Region 1 have legislation requiring blood lead screening for children. This table lists the websites for each of the Region 1 states. The available data typically reports screening, incidence, and prevalence at the state and town level. In the next several slides, I'm going to review each state's website in alphabetical order. Since this presentation is recorded, you can advance the recordings to your specific state. I'm going to just show you quickly just the landing pages for these websites. and then I'm going to share my screen to show you the websites themselves, and I can walk you through some of the data that is provided on those websites. So this is Connecticut's, what Connecticut's website looks like. This is Maine's. Here we are with Massachusetts. This is New Hampshire. Here we have Rhode Island. And this is Vermont. Okay, so let me stop sharing this screen. And I am going to move over to the websites. Okay, very good. Let's start with Connecticut. So here you can click on, just move that out of the way. You can click on prevalence here. And then this is going to show you information focusing on the total number of new and existing cases. And then if you scroll down, this has a lot of very good information. But I'm going to show you things that have to do by town. So here we go. So these are the number of cases by town. And it's for the years 2018, 2019, and 2020. As you can see, the top 10 towns with the highest number of cases are in bold, and they make up 63% of all the state's cases. So you're starting here with New Haven, and it goes down to, we have West Haven, and New London is also in bold. In most cases, but not all, you'll see over the years from 2018, 2019, and 2020, there is a reduction of the number of cases. However, there are exceptions, for example, here in Bridgeport, which went up in 2020. It's where you can take a look at what, if you're looking at a particular town, you have a particular town that you're interested in for your data that you need for your application, this is where you can look. And then this is if you wanted to look for prevalent just for 2020. And then you can scroll over to look at all of the towns this way. They also have maps if you wanted to look at certain maps. I have different ones listed. The top 5 cities as well. Okay, so now let's move on to Maine. So in Maine, you can click on, I like to click on town data and lead poisoning. And this is what you'll see. So the darker orange are going to have higher percentages. And you can scroll over one particular town, such as Bingham, and you'll see the number of cases and the percent of cases. And you can also look at it if you want to look at it in graph form. Oops, here. How it went to testing. It's processing, it just takes a minute. Right, so then you can also look at it this way. And then, so not only can you look at data for lead poisoning, but they have testing, pre-1950 housing, and poverty rates. And so now we're moving on to Massachusetts. And this site provides annual reports, and you can scroll down. This has again, this offers a lot of valuable information, but if you scroll down, I just wanted to show you the appendices. It's a nice map. And there's also graphs for looking at the data by race and ethnicity. Here in the appendices, they'll have they list the high-risk communities for childhood lead poisoning. And it also, this is a poverty index and percent of housing units built before 1978. And this, I'm sure this is probably very difficult to see on your screen right now. But if you go to the website and download the report, this appendix, and go to Appendix 2, you can see it lists towns, all the towns, population in months, total screen, percent screen, and then blood lead levels. So the 0 to 4, the 5 to 9, 10 to 24, and then above 25. And it also has the percent of pre-1978 housing units. So that can be handy for you. All right, and now let's look at New Hampshire. So New Hampshire has a data portal, and you can select lead exposure testing, and then go to elevated blood lead levels, and then you can click on results by town. And this is what it'll show you. Again, it's kind of same principle. The darker the blue, the higher the percentage. And if you scroll over one of the dark blue, you can see it'll give you additional information and similar things here. You can roll over the data points, and it'll give you additional information here. New Hampshire also has a nice fact sheet that can give you some information. And I'm just going to scroll through it very quickly because I wanted to just show you. Here they have information listed by Regional Public Health Network. And it's the 2022 testing data for children. So if you wanted to look at your county and group, percent tested, and then number of children with elevated blood levels. So you have two different, the 3.5 or the 5.0. So that might be useful for your reports. And here we have Rhode Island, which provides on their website new cases, so the incidence by year, and the prevalence by year. And then they have new cases by town or municipality for 2023. So that's pretty recent data. So you can look up that information. Now, Vermont does something a little bit different. Let me just take you back so I can show you how it's, show you how. So there they measure lead in school and childcare centers. So here you could say you wanted to look at, let's pick Burlington, and say I'm just interested in schools. You can click search, and this is what will come up. And then say I'm just interested in looking at Burlington Senior High School. And then this is what the latest sampling is in 2024. And you can just look at all the taps. So all of these are below 1 parts per billion. That's what this is. So Looks like it's acceptable. And then I know you're already familiar with the EJ screens. But I just wanted to show it to you because it's another source for lead exposure. In the EJ screens, lead exposure is measured using a proxy of lead paint, which is based on the percentage of housing units built before 1960. The lead paint supplement index, which you would find here, combines lead paint with 5 demographic factors: percent low income, percent persons with disabilities, percent limited English speaking, percent less than high school education, and low life expectancies. So the benefit of using the EJ screen is that you can scroll down to the census block level. And for example, this is a block, census block track in Hartford, and you can also generate some reports. So that's the advantage. I mean, it's not blood lead screening or blood lead results, but it does provide you with the census tract data. Okay, so let's see. Let me stop sharing this, and I am going to go back to my PowerPoint. Okay, so let me just go EJ screens. We just talked about that. And this is also a site that you are probably already familiar with, but just in case you'd like to see where brownfields in your state are located, here you can click on this brownfields property link and to focus on a specific area. And I'll show you what that looks. So if you clicked on the brownfields property, then it'll show you, this is what the you can enlarge the map to look at the US, and then say you wanted to look at what it looks like at the for region 1, the EPA region 1. And then here we had, say you wanted to look at Framingham, so you could see what's going on there. And this is a legend here. It's kind of tough to see it on the webinars on this screen, but it's you can look for the plus minus, and this kind of, I mean, this plus sign that'll show you where some of the brownfields are. So you could kind of look at this and look at the EJ, compare it to what the EJ screens are, the information there, and also look at some of the state level data. You know, and you have to keep in mind that you can't always make a direct causal link between brownfields and lead exposure, but living near a brownfield is just an additional burden that additional health and socioeconomic burden that many people are exposed to. And this is just a list of lead laws and regulations for your reference. And if you have any questions or comments, you can reach any of the team members on this website, on this website, and we can get back to you. Thank you very much for your time, and take care.